in the next couple examples, we'll look at some of these problems, but without like the understanding of knowing is it going to be a combination or permutation ahead of time. Because say you're on a test or you're actually out in the world trying to figure some probability thing out yourself, you're not necessarily going to know. You're not going to be told this is a permutation versus combination. You're going to have to figure out which is the proper formula to use. So with example 7b, it says Roger draws one card from an ordinary 52 card deck, then replaces it and shuffles the deck. He then draws another card. How many outcomes are possible? So we want to know, is this a combination? Is this a permutation? Or maybe this is not even either. So again, what I think is helpful to do is to try to imagine the situation and think about what's happening. What are the number of choices? So from the deck of cards, 52 cards is what he starts with. He's going to draw one card to which he'll have his first choice. But then he's going to replace the card. So when he makes his second choice, there's still going to be 52 cards in that deck, right? Because he's replacing it. So the math of this is technically it's a little bit different because there would be 52 times 52 possible outcomes. And also notice one of the differences here is that we could get ace of spades and an ace of spades yet again, and that's a unique outcome. And another thing that this does not mention is, well, do repetitions count as the same outcome? Because technically I could think about the order and the order as mattering. Like say for example in my second choice, I picked a king of hearts. Is ace of spades king of hearts different than king of hearts ace of spades? Well, it's not necessarily clear, but outcomes, I would assume the way the question is phrased that is a different outcome. The order does matter. So this is why I would think more of a permutation than a combination. And also it's not a true permutation because of the replacement of the card. But my opinion on what this answer should be is just 52 times 52. But notice there's a little bit of ambiguity sometimes in questions or 2704, and sometimes you don't want to just use a particular formula. And it's really the replacement of the card nullifies it. It's neither a permutation or a combination, so we don't want to use those formulas as well. But in a typical game, you're not replacing a card. So anyways, that's why it still is helpful to think about the fundamental counting principle, because all of these ideas stem from that. And so hopefully that helps with that. Let's look at one more example. Example number 8, it says a license plate manufacturer would like to know how many different license plates could be manufactured. Each license plate consists of 7 characters. It must start with a number, then 3 letters, followed by 3 numbers. How many different license plates are there? And again, we could think about the sample space of like, well, what are all the possibilities? It could be A, 4, 7, 2, J, Q, R, or whatever. But it's kind of helpful to, to think about what does the sample space look like. But, quite obviously, there's going to be a bajillion different options because there's so many different letters and numbers, and there's so many different characters, in this case, 7 slots. So it can be kind of helpful to think about, well, what does my license plate look like as a series of slots? And then how many choices are going to be happening in each slot. So in the first slot, it must start with a number. So there's technically 10 digits, right? 0 is a digit that's possible as well. Actually, if you know your license plates like my dad, you'll know that they don't really typically use zeros. They use zeros but not O's for letters. But we're going to ignore that and just assume it could be 0, 1, 2, 3, 4, 5, 7, 8, 9. And let's assume that we can tell the difference between 0 and O. And then it says then 3 letters. So from the alphabet, we're assuming a standard alphabet. There's 26 letters. It could be A through Z, no other things. But again, you could obviously make adjustments to this based on actual specifications, but we're just going to pretend it's simple. And then followed by 3 numbers. And of course, in each of those numbers, it could be 0 through 9, to which there are 10 unique numbers of 1 digit. And then this would then give us how many unique license plates there be. And also, all of those should be multiplied together, because I could think of each letter as being stamped on there as an individual choice. It doesn't say anything about repetition, right? It doesn't say that once you use letter A, you can't use letter A. So this problem is neither a permutation nor a combination, actually, but something else entirely. Because first of all, but order does matter. So notice it's going to be more closely akin to a permutation. But also we're not we're replacing those letters, right? And when you do replace them, you're throwing out the loss of digits, like right, like in a permutation, the key thing that will happen is you're always losing one, like 52, 51, 50. But in a like in just a straight up fundamental counting principle type problem, you're not really replacing it. Because you're allowed to reuse. Like it could be A111 AAA, and that's technically allowed based on what I'm told. But anyways, that would be 10 to the fourth power times 26 to the third power. And that would give us our total number of license plates, again, assuming all combinations are valid, which is technically not true, but that's okay. And that would be a whole bunch of license plates. So 1,000, or let me go ahead and write it out. That'd be 17,560,000 license plates. Uh, Wait, did I get enough zeros? I did, but I missed a digit. So I was like, that actually, it seems like a lot, but actually, for some reason, it didn't really seem quite right. It seems, and this is another thing is like there is the answers have kind of a sense of the scale to the size and like how big they should be. This seems a little bit more accurate. It's kind of hard for me to explain why that seemed a little too small, but it's really 175 million license plates options of that particular configuration. And you can see why, you would think like, how would they ever run out of license plates? But for example, in the United States, the population, could be, or in certain countries, the population of could be significantly higher than 175 million people. So they would eventually need to start a different chain. And well, what you could then do is say, well, what if I wanted to put the letters first instead of the numbers? That would be a unique series of license plates, which would then generate 175 million new options. And anyways, that's enough for this video.